Hi everyone, I hope you're all doing well and you're ready to learn a little bit more about coding today. So in my previous video, we looked at this two sums problem from Leetcode where we solved the problem using a big O of n squared complexity or a brute force approach. So basically we had to look through the list twice. And we did solve the problem, but I think it could be better. So I'm going to let you pause this video and think to yourself, could we implement an algorithm that runs in big O of n complexity? So rather than having two for loops, maybe it just has one for loop. So go ahead and pause the video, think about the question, and hit play when you're ready to look at the solution. So my personal solution is the hash table approach. So first, before we get into the solution, let's talk about what is a hash table. So a hash table is just a way to look at for lack of a better term, list key value pairs or keep track of key value pairs. So a hash table might look something like this, where we have key 1, value 1. Then we might have a key 2 with some value 2. And so on and so forth. Now there would be lots of different ways to implement this, but in Python, this is mostly how it looks. So now you might be thinking to yourself, why would we need a hash table? What are we going to store in the hash table? Why? We already have a list of numbers. So I'm thinking that we can reduce the amount of iterations through the list if we use a hash table. So what are we going to store in the hash table? I'm thinking we can store, let's just take this first example. I'm thinking we can store the numbers in the list as the keys, and the value is the index. So let's just take this first list, for example, and let's say the key is 2, and the value is 0 because it's at the 0 index. Now the next key would be 7, and the value would be 1 because it's at the next index, so on and so forth. Now why this is important is because I think we can use an approach where we look at the target value and the current value. So we need to think about this problem a little bit differently. Rather than summing up two values to see if they equal the target, we're going to look at the target and subtract a value and see if the result is present in the list. So we're going to use the hash table to implement that. Maybe to help it make a little bit more sense, I'll walk you through the first example. So if our target value is 9, we would look to see, okay, 9 minus 2 equals 7. Then we would look and say, is 7 in the table, the hash table that is? Okay, yes it is. Now return the index where 2 was at and where 7 was at. So return 0, 1. So now to write an algorithm for this, the first thing we need to do is build the actual hash table. So we'll start off with just declaring a table, and in Python we're just going to declare it like an empty set notation. Now again, we're going to need the length of the list for iterating purposes, so we're going to say n is the length of nums. Now building the table, we'll use a for loop, so we'll say for I in range n, so this will give us all the indices. The table at, this might be a little confusing, at nums at I equals I. So nums at I, here we have nums at I. That is the specific value that's at I. So that's this value 2. So the table at 2 has the value I, or the index. So this is building this key value pair. So just to make sure we did everything right, let's go ahead and, that makes me remember that we need a default return statement. So if no solution's found, we'll just go ahead and return the empty list. But to make sure that we're doing this correctly, we can go ahead and print the table. So let's run the code to see if we've built this hash table correctly. Again, the answers are wrong because they're all going to be the empty list, but we have built it correctly. So this is what we want our hash table to look like. So now the fun part of the algorithm, the more interesting part. We need to actually implement this complement nonsense. So we'll say, 9 minus 2 equals 7, so 7 will be the complement. So again, we need to loop through all values in the list. So we'll say for I in range n we need to find the complement value. So we can say that complement equals the target value minus the nums at I. So in this case, it'll give us 7. Now the nice thing about Python is we can just write it as we speak it. So we want to say if the complement value is in the table, then we want to return the index that we found the number at and the value or the index of the complement. We'll just call it comp. Otherwise, again, we have our default return statement just returning the empty list. Now you might remember in the last video we ran into problems when the same value doubled added up to the target value, and I think we're going to run into those problems here again, but let's go ahead and run this just to see the solution. So again, we passed the first case. We saw that 9 minus 2 is 7. 7 was in the table, so those were our indices. But now here, where we have 3 is the first value, 3 plus 3 is 6, but we don't want to consider the same value twice. So we need to add a little bit more to this if statement. So if the complement's in the table and if the table value at the complement does not equal the index of the number, the first number. So let's go ahead and run that and see if that maybe will solve the problem. And it does. So it can't consider 3 because then this part of the if statement wouldn't be true. So now let's go ahead and submit this and run it for all the test cases that Leetcode has to offer. And we see that our solution is accepted. So we beat 50% of users who use Python 3, so better than our previous solution. Again, this complexity, because it just required one for loop, was big O of n. So we did do it in better time than the hash table solution. If you like this content, go ahead and subscribe to my channel. Go ahead and comment if you want any other videos or any other Leetcode problem solved or just an explanation for any type of coding question. Thank you so much.